What is AI? AI is anything that mimics the human behavior. That means humans can see, humans can read, and humans can understand and process that knowledge. Humans can speak. These human capabilities, if a machine can do that, that's artificial intelligence. AI is not something which came a decade ago or 2 decades ago. The research on AI has been going for almost 5 decades. But we have never seen this kind of a penetration. What happened after 2017? 2017 is a very, very important year that changed everything what you see. That's when generative AI started. Till generative AI can mimic the human behavior, but it cannot create content. What content? Natural language content. Writing summaries from a large document, writing a poem, drafting a professional email, correcting your errors, proofreading books, suggesting alternate phrasing, anything to do with your natural language. And in couple of years, there came image generation. So it can draw paints. It can create realistic images. It can mimic any artist in last century. And that capability is on par. I don't say it's on par, but it's almost close to the human generation. And there came ChatGPT and GitHub Copilot. You have been using that. I'm very sure most of your organizations have given access to that. You're writing test cases, you're writing code, you're refactoring your code, everything with OpenAI in the background and GitHub Copilot as a tool. Apart from the tools you have been using, there are various tools. Of course, ChatGPT revolutionized everything. There came Cloud E3, which solved one fundamental problem with ChatGPT. Context. Right now, GPT-4 has a context window of 128K. Those many tokens. Cloud 3 has 200K. Now, Gemini 1.5 Pro, which is in preview, has 1 million token. That means it can contain and the entire PDF document, your academic journal, and it can answer. It maintains that context window. And there came music generation.
Let me tell you what I found
This song,
in the world of AI, where answers come so quick. I'm searching for something more, something that's real. Cause technology's great, but I long for human touch. We need.
this entire song, vocals, instrumentation, everything generated with artificial intelligence with a single prompt. The prompt is simple: humans embracing AI.
Actually, I didn't get this. Like, how generative AI is involved here?
I'll come to that. I'll give you a chance to the
Okay,
questions
sure,
later. Yeah.
sure.
So this one. So it's generating music. And there is another tool which is Perplexity AI, a combination of a Google search and For suppose Google search has a problem, it gives you links, not answers. GPT will give answers, but it cannot give accurate. It might not be accurate. You don't have citations. The combination is Perplexity AI, which raised a $1 billion just 2 days ago. And all familiar with Sora. Of course, it's still in preview. It's not publicly available. All these tools have one thing in common. All came in the last 5 years. To reiterate again, 2017 is a very, very important year. All the models used by these tools, not only these tools, right now, even if you are using Google, is also using an architecture called transformers. Even Google Translate, any AI tool, if you see, any generative AI tool, and even the legacy AI tools like Google Translate and Google are also using a neural network architecture called transformers. So what is it? Transformers architecture is something is built on a research paper. This is the research paper. This is a simple architectural diagram for that neural network architecture. So what did it revolutionize? Till it came, any neural network training, you all know neural network is something will have billions of neurals involved. It simulates how the human brain works. That means human brain has almost like 80 billion neurons in our network, in our brain. If you are breathing, if you are reading, writing, walking, and everything is by the connection between the neurons. Even GPT 3.5 have those many neurals. How they are able to train this large data? How they are able to create this large network? The problem with the legacy RNNs, RNN is a previous generation before the transformers. That is always training sequentially. There will be an input and it will create a network. There will be output. It will be an input to another output. It's always sequence. It has two issues. One, time. It takes a lot of time to train these large language models. Two, computation. With the transformers architecture, both the issues solved. Any large network, any large neural network with any number of parameters. If you have followed the news, Meta has open sourced Llama 3. Smaller LLM has 3 billion parameters. A larger LLM has 70 billion parameters. They're able to train that in a couple of years. So this is so efficient. All the tools right now, if it is AI, be it cloud, Perplexity, GPT-3, GPT-4, Google, anything, all the architectures, all the models are built on top of this neural network called transformers. Let's summarize this. How does it work? One, first thing, there are two things here. One, training. Two, generation. Be it text, image, or music, anything. One is called encoding, other is called decoding. Let me pull up a document. This one. Encoding is used when you're training a model. Decoding is when it's giving you output, when you're using that model. The first step to encoding, that means training, is giving a input text. That input text will be tokenized. So what does it mean by tokenization? Let's go to OpenAI tokenizer. Every model will have its own tokenizing concepts. For suppose GPT 3.5 and 4 using this concept. Tokens are nothing but numeric representation of characters you entered. This is a numeric representation. Approximately every 4 characters will form a token. It varies. It depends on the tokenization engine. But approximately for English, these are the tokens. Step 1, when model is getting trained, your input characters, the words you enter will be tokenized. They'll convert into numeric representation. That's step 1. Second, embedding. What is embedding? When you enter the data, so the word embedding, this word cloud will be formed. That means how a word you entered is related to another word. For suppose AI 102, closer. For suppose a cat and dog are playing. Cat and dog will be at the closest level in this word embedding because they both are related. How it will know both are related? Send the petabytes of data. It identifies the relation between a word and word. When you give petabytes and petabytes of data, all the data which is publicly available, of course, it knows what is the next probable word to the existing word. Like that, a multi-dimensional model will be created. And there is another thing, position encoding. That means what is the position of the word you entered? And then, as you see, what is the name of the paper which changed everything? Attention is what all you need. Attention is a core mechanism in transformers. It allows model to focus on the most relevant parts of the input sequence. So it understands what is the relation between one word to another word. Based on that, they are placed, the tokens are placed in multidimensional, that cube. A 3D position will be given. And This kind of architecture will form other neurons. When you give petabytes of data, one neural network will be input and it will relate to another one. So that's how complex networks layer will be formed. And this is all for training. And there will be other concepts like there will be reinforced human training will be there. We'll pass the data, we will train the models, and while training, so there are various ways. For attention algorithms are there. There are existing open source algorithms, and you can create your own algorithms. And for AI 900, AI 102, this is just to let you know how it is working in the background. Of course, there won't be any questions in the certification, but knowing about this is very, very important. You might be using Llama, you might be using Gemini, you might be using GPT models or any other decentralized models. All are built on this architecture. In artificial intelligence, encoding is the most costly and computer resource heavy process. Decoding, what is decoder? Same thing, but here decoder is responsible only to generate. You already know, you already formed a word cloud. Here you know the distance between one token to another token. In decoder, all you have to do is getting the distance and finding the next best word to form a sentence. Simple. That's how Google is able to respond in milliseconds. That's how GPT can answer you. It can produce 500 and 1000 or 2000 tokens within 5 minutes. Decoding is very easiest. I mean, for suppose, once the model training is done, the smaller LLMs, for suppose these models are there in my local system. Gamma 2B is by Google. I don't even have a graphic card. This 2 billion parameters model is going to answer me. It's going to use my CPU. And if it is a 70 billion parameters, of course, I need so much of computation, but you can deploy these models now in your organization. So you don't even have to worry about sending data to external clients. How easy it is. So this is a very high level overview. If you want to know more, for suppose for this document, I'm going to send this document to you, read it, and I give a summary also. All you can see. This removes the sequential nature of the previous RNNs. Model to weight and combine information from different positions. It achieves new state-of-the-art results. You can read this. Otherwise, there are tons of resources available. You can read more about the transformers architecture. But when it comes into AI 102 and AI 900, briefly, if you know this, that should be good enough. Just remember the steps. There will be input text. There will be tokenization. There will be embedding, position encoding, and this all comes under attention. And after that, feed forward, attention, feed forward, again attention, and feed forward to connect to a complex neural network to establish complex relationships between the large amount of data. Encoder is something which is used while model training. Decoder is something which is used for output generation when you're using the model. Any doubt still here, you can ask.
So, like I have one question, Suresh. Just
Sure.
for my understanding, I need to just check if my understanding is correct. So, like the way the generative AI is working is the transformer architecture behind the scenes is working, right?
For model training, yes.
For model training, the
Yes.
transformer architecture is working behind the scenes.
Yes.
And this transformer architecture is about like encoder and the decoder. Encoder is about machine, sorry, it is about model learning, right?
Yes.
Okay, so we are training our model and how it works. It's basically with the help of we input the data, then it do tokenization,
Yes.
and then it is embedding. Embedding is like a clustering kind of thing it is doing. Is it correct?
Yes. It's forming relationship between the token to token.
Data.
Yeah.
Got it, got it. And then what is positional encoding?
That means, for suppose, the word can be used in multiple sentences.
Yeah.
There will be thousands of instances.
Okay.
What is the probability of the and is, the
Okay.
and are? So there will be multiple combinations like that. So simple. In the background, whatever you see, whatever running, it's all numeric operations.
Mm.
It doesn't have any semantic meaning. But the beauty is it's able to establish the semantic meaning just because of the large amount of the data. From that, it formed a neural network, and it knows what word is the best after giving the first word. After the is it should be is based on the input.
Mm.
Yeah,
And attention is like,
forming this network. So establishing the relationship between the multiple tokens.
okay.
And it's a very large concepts, and there will be formulas involved. Well, self attention, there will be sign, and there will be cause, and there are certain formulas, and there are
Mm.
certain ways of modeling. It's a large subject. It's not our concern. So in a high
Mm.
level, this is what it's happening.
Got it.
Yeah, it's all about at the end what word to generate after which word based on your input.
Got it.
That's it.
Thanks.
Yeah. So now let's go to the next topic. The Microsoft integration of OpenAI services. Every cloud provider, again, same like operating systems, there is a Windows for Microsoft. There is Linux, which is decentralized. That means open source. Anybody can play around it with it. It's not proprietary. And there is a Mac. Take any software. For video editing softwares, if you take, there's a Premiere Pro, and there's an alternative DaVinci. IDEs for suppose to software SDKs, there is a .NET SDK to build applications, and there is Java. So now when it comes to LLMs or generative AI, text generation is the most evolved compared to the image generation, video generation, or music generation, or speech synthesis. In text analysis, there are two big players. One OpenAI, second Anthropic. OpenAI intellectual property acquired by Microsoft. All the models, all the weights of that models, that means the data which it trained on, everything is available with the Microsoft, and we have all the OpenAI models, even which includes GPT for Vision. Not at all the locations of Azure, but it's available. And we have Microsoft even built products on top of OpenAI. They are called copilots. What are copilots? Wrappers built on top of OpenAI models. If you have a license, there is a word copilot which can write a document. There is a PowerPoint copilot which can create slides for you based on your prompts. Simple. Every Office 365 app has this icon. Excel Copilot can help you with the formulas. And let's go to Edge browser. The image what you saw in PPT is generated with this command. If you are in Microsoft ecosystem, it's always recommended to use GPT 3.5 Turbo. The performance and weight and everything is same. Responses will be same. When you use enterprise accounts, it came by default if you have a license above E3, Microsoft 365 E3. And all the data is protected. That's how all the organizations ban ChatGPT, and you can use the same in your Edge. DALL-E 3 is also integrated. It works even if you have personal account. And there is a Microsoft Copilot application is available in phone where you can use GPT-4 for free. And this is a browser Copilot. This is Bing Copilot, what I'm referring to. You can open any page. You can ask this to summarize this page. It will give you the summary because it knows the page context. And what you see on right bottom of my screen, it's Windows Copilot. Okay, which is coming in the primary screen, which is still in preview. This is how it looks. When I click on the right bottom icon, a Copilot will open, which have access to Windows settings as well. You can set it to dark mode or light mode. You can play around with the brightness, all the Windows settings. And apart from these Copilots of Microsoft products, if you want to build your custom Copilot, you can do that. You can create, if you have a license, you can create your own custom Copilots. Let me share my slide. Here, there is Edge browser Copilot, Bing Copilot, which you shown, and there is GitHub Copilot. You might be using it already. So there are few things you can, you can use to improve the existing performance. There are few words you have to learn. One, direct language. You can get the most useful completions by being explicit about the kind of responses you want. Create a list of 10 things to do in Edinburgh during August. Describe how the chart should act. Do you want to use it as a coding copilot? Or it should be a proofreader? Or it should be English teacher correcting your grammar mistakes? Mention that. That is called system role and setting the context. And there is another beautiful thing, which is zero shot learning. And these are all something, these are not commands. A command will have a fixed format. dir directory. That's it. But here it can be directory full word, small letters, caps, a combination, or another word matching the directory. Whatever you're writing here, these are guidelines. How you frame your input. The LLM response is as good as the input you have given. And grounding data. Providing context, including email text with the prompt, summarize my email. Write a list of things to do. Start with these sentences. So before going there, I'll give you one example. Okay, so these examples, anyway, I'll share the links as well. These are nothing but you just have to practice using Edge. Try to create an image. Try to create text. Play around with the prompts. Okay, before going that, for suppose how to frame a good prompts. I have to build a prototype. I have a .NET 6 application. And here, if you see, read the prompt. I'm also giving the name of the controller because if you don't give, it will give some random name like home controller. Again, you have to rename. And I'm giving the view name. And I'm giving the version of the bootstrap it has to use because this is my project version for my prototype. And I'm asking it to give the validations. And the form that I'm building will have these parameters. A drop down with the name, industry. Why did I give name? If I don't mention name, it will be another a random name. And I'm giving options. For options, I'm double quoting to emphasize. Wherever name is there, I'm emphasizing it. So how you want to emphasize, that's your choice. It need not necessarily double quote. A text box to capture company, email address, drop down, name type of visitor with options, checkboxes, everything. But the problem is GPT 3.5, when you're not paid, has a token limitation. Right now, it has to give me the entire page. It will be more than, I guess, 5,000 tokens or 6,000 tokens. It's not allowing. It didn't allow. So what I did later, I asked, give me only the form and give me only validation scripts. So that script will be lower than the max token limit. And in the backend for this page, I need to create a view model. Now with the previous conversation, it has a context of the form. So for above requirement, give me view model. It already knows it's a .NET 6 application. It already knows it's a C# based application. Simple. Because I give those details. That's why specifying context is very, very important. And it gave me the view model with the exact fields with data annotations as well. I could have drafted a far better, prompt. Only these specific elements should have error messages. And in data annotations, these should be the error messages, and even they will be corrected. To summarize till here, always mention if you are using it for coding perspective for building prototype, of course you cannot use it for a production based applications. In that case, you reusing the code, reusing the styles would be a better option. But if you're building a prototype, always give clear instructions. Now JavaScript code to perform client side validations. Now write code in index action method of HubSpot controller to get the form data. It got it. By now, the boilerplate code is done. For this boring piece of code, I don't have to invest time. It's done in 15 minutes, max 20 minutes maybe. And I'll show you the output. I got the form with the drop downs, text boxes, and check boxes, title, bootstrap styles, pre-applied, responsiveness, applied. So based on the purpose, these are some guidelines, and I am not an expert. So these are some basic things I do. And whenever you are trying to do, just see prompt engineering techniques. Be clear with your instructions. There are certain guidelines, just follow them.